So there's the question. Let's move on after that quiz one. So, I already saved it, huh? We're good. All right, so, all right, chapter 8. There it is. 8.1, mathematics and scheduling. Okay, this is going to start out real easy, and then it'll get a little bit tricky. Let's just get through the easy stuff quick. Chapter 8 is all about scheduling. Like, remember these two chapters, early on in the course, we're talking about voting and power and how math can help society make voting decisions like that. Now, in chapter 6 and 8, it's all about management science. How can math come in and help manage things better? Chapter 6 was about traveling, like visiting a bunch of cities. How can we do that in the most efficient way? We learned the 3 methods, right? Nearest neighbor, pet nearest neighbor, and cheapest lake. Now in chapter 8, how can we manage like a big job? Like say you're a construction manager and you have a bunch of subcontractors that come in and they're going to build a house. Well, there's certain things that need to be done before other things, and how do you manage them all to not waste as much time? You don't want the roofer showing up when the walls aren't up yet, because he'll charge you for his time while he waits around for the walls to get up, etc., that kind of thing. So we just want to say, what's a wise way to make plans to make a whole job come together? So to do that, we're going to start with, we need a tool, just like for a construction job, you need a hammer. We need something called a digraph. This is a directed graph. So that's the word they're using up there. Digraph. Just means a bunch of arrows. That's all it means. And the arrows are going to basically say which job leads to which job. So start with the arrow one. This is a arrow diagram. So let's just get used to using the tool. This first 8.1 won't be very real. And then we'll get an 8.2 and it'll be a little more real. So 8.1, first off, let's just get used to the language that they're speaking. They say, what's the vertex set? Vertex set is just the different points up there. So that's A, B, C, D, E. Nothing more to that. That's all they want from you. A vertex is the points. All it is the different points. So arc set. Arc is the different arrows. That just means give me the different arrows. How do you list the arrows? Well, one of the arrows is A to B. That's one of the arrows, A to B. Another one is A to D, and etc. So it's just saying list all the arrows up there in the diagram. So you just have to go through and list them out. So that'll be simple for you. I won't spend any time on that. Complete the following table. Well, also, let me mention about the arrows. When you write A, B, it means it starts at A and it ends at B. It goes from A to B. And that's what this does, right? From A to B. So that's a bunch of arrows, okay. Now, let's talk about vertices and their in degree. In degree, this will all have real life significance in a little bit. In degree means the number of arrows coming in to that point. So like look at A up here, point A. Here's point A. How many arrows are coming in to point A? None. They're all going out from A. So that's why we're saying none. How many arrows are coming into B? Well, it says 3 because you see there's 3 arrows coming into B. In degree, number of arrows coming in. Pretty simple, right? C has 1 arrow coming in, D has 2, E has 2. And then out degree, you know what that means. How many arrows going out from that point? So how many arrows going out from A? 1, 2, 3. 1, 2, 3. Arrows going out from A. Out from B is none, and on you go. Out from C is 2, D is 1, E is 2. Easy? In degree, out degree, vertices, points, and listing all the arrows. So that's all good. That's going to be a tool we're going to use to help us manage things in a little bit. So we're just getting used to, how's this hammer work? We'll actually build something with it in a little bit. All right, let's go to. Okay, so this one said digraph. It's called a digraph. Again, stands for directed graph. A graph with arrows in it. Digraph right here. 7 arcs in the digraph. So there's 7 arrows up there. Is that true? Are there 7 arrows? You just count them. 1, 2, 3, 4, 5, 6, 7. Yeah, 7 different arrows. That's all we're saying here. Arc, call it arrow, whatever. In degree, what's the sum of the in degree? I'm saying it's 7 there. Why is it 7? Could we count all the in degrees? You know what I mean by an in degree? Pointing in at a point. So like at point A here. How many arrows are pointing in to point A?
1.
Yeah, his in degree is 1, huh? 1 arrow is pointing in him. How many arrows are pointing into B? 2. His in degree is 2. How many are pointing into C? 1. How about D? 1. 1's pointing into D. Is tracking with me? I'm just saying how many arrows are pointing in. And finally E. How many arrows point into E? 2. So if you add that up, 1 plus 2 plus 2 plus 1 plus 1, you get 7. Yeah, of course, huh?
Yeah.
Great observation. Yeah, I mean, that's kind of silly. Of course. If there's 7 arrows, every arrow has an in direction, there's got to be 7. Right, exactly. Good observation. So we don't really need to count those, do we? It's just got to be the same number as the number of arrows. And what do you think all the out degrees are going to add up to be? Every arrow has both an in and an out. So if there's 7 arrows, there's 7 outs as well. So no need to count those. It's got to match. They're just showing you, yeah, of course, those got to be the same, don't they? Is that all good? So in a little bit, those will become jobs and people that need to do jobs leading to other jobs and, it'll represent real life things. All right, I'll move on. Switch. So, okay, so which vertices are incident to A? That means incident to means pointing into. Incident to means pointing into. So how many are pointing into A? Or which points, I should say. They're saying which vertices, which points are pointing at A? E. E is with this arrow pointing at A. So that's the only one pointing. Incident to A. Pointing into A. Which vertices are incident from A? So which ones does A point at? Yeah, well, A points at B. Oh, right there. A points at B. So and then which arcs are adjacent? What does adjacent mean? I guess next to? I always forget. Honestly, I'm not going to quiz you on these names. I think they're kind of dumb. I don't even remember. Adjacent to. I just have to look at the answer and kind of think it backwards. Adjacent to BE. Where's BE? I think it means next to. Let me see. BE. Where's BE? BE. So BE is right here. There's BE. Which ones are adjacent to B? Oh, it means like come right after. Yeah, that's what it means. I always forget. So yeah, see how DE and EA, or I should say ED and EA and ED, both come after the arrow BE. So it just means what comes. So adjacent means come right after. I'm not going to put that on the test. I promise. I'm not interested in silly names. But that's all they're looking for there. Comes right after. All right, let's move on. Let's get to doing some actual stuff here. Let's try that. Okay, so they're saying we've got a vertex set and an arc set. And they want us to figure out, okay, what's the out degree of E? And I said it's 1 there. How'd I figure that out? How do you look at just a list? No picture. Just looking at that list and figure out the out degree. Now, what does it mean to out degree means pointing out? So that if we did have a picture, it'd be something like E is here and it's pointing out to some other point like C or whatever. Wouldn't that be an out? That'd be an arrow going out from E. So how would you list that arc? E points to C. The E would have to come first, wouldn't it? Remember, you always list the arrows. First letter is starting point, the second letter is where it points to. So if we're looking for arrows that go out from E. That would be ones that start with E in the list, which would just be that one only, huh? EB. That's the only arrow going out from E, so it's actually EB. EB. On that. EB. Good there? That's the only. And then in degree, so if you're pointing into E, that would be some other point first, whatever, A or whatever, pointing into E. So E would be listed second in the list. So which ones up there have E second? In fact, it is A to E, isn't it? So that's the only one pointing into E. We good on that? They're just making sure you can work it backwards from the list back to what the arrows mean. Good, I'll move along if you're okay on that. All right. So the order, it's all about the order, right? When an arrow starts at E and goes to B, you write it EB. But if it starts at A and goes to E, you write it AE. The first letter is where the arrow starts. Okay. Okay, so they've got a respect digraph. I guess this would be like a social construction thing. So maybe sociology or something use this. So it's a respect digraph, and what it means is anytime you point at somebody, you respect them. Is if you read those words, that's what it's basically saying. So basically, when B points to A, that means B respects A. And when E points to A, that means E respects A. And when D points to E, and on you go. So if you're pointing at anybody, you respect them. Okay. So that's how the relationships in this group go between A, B, C, D, and E. Let's answer some questions. If you had to choose one person to be the leader of the group, whom would you explain? I said person A. Do you see why I chose person A to be the leader? Yeah, largest number of people pointing, respected by the most number of people. 2. I guess it's not the whole group, but it's 2. 2 people respect A. Everybody else has just got 1 or nobody respected them. Who would be the worst choice? D, because D has the smallest. Who respects D? Nobody. Nobody's pointing to D. D is not respected. And finally, part C. Assume that you know the respect digraph of a group, the only information, blah, blah, blah. Which individual would be a reasonable choice for the group leader? And so it's the individual corresponding to the vertex having the largest in degree, right? The most pointing in. And that's what we just observed. Does that make sense there? Questions?